Welcome to the lesson on algebraic methods of solving a pair of linear equations. At the end of this lesson, you will be able to solve a pair of linear equations using three algebraic methods: the substitution method, the elimination method, and the cross multiplication method. You will also be able to solve a pair of non-linear equations which can be represented as linear equations. You have learned how to find the solutions of a pair of linear equations graphically. However, this method may not always give the most accurate solutions, especially when the point representing the solution has non-integral coordinates like square root 2, square root 3, or 1 divided by 3, minus 5 divided by 4. Identifying such coordinates can be quite a challenge. So, how do we solve such equations? Algebraically, of course. There are three algebraic methods that can be used to solve a pair of linear equations. Now, recall that a pair of linear equations in two variables can either have a unique solution and infinite solutions, or no solution. To verify this, we can compare the ratios of the coefficients of the x and the y variables. Consider the standard form of a pair of linear equations in two variables. If a1 divided by a2 is not equal to b1 divided by b2, then there will be a unique solution. If a1 divided by a2 is equal to b1 divided by b2 is equal to c1 divided by c2, then there will be infinite solutions. If a1 divided by a2 is equal to b1 divided by b2 is not equal to c1 divided by c2, then there will be no solution. Let's begin with the substitution method. Consider the pair of linear equations x minus y is equal to 5 and x plus 2y is equal to 20. The first step to solve a pair of linear equations by the substitution method is to solve one equation for either of the variables. In other words, we can solve for either x or y in either equation 1 or equation 2. The choice of equation or variable in a given pair does not affect the solution for the pair of equations. To keep it simple, choose the equation and variable that can be solved quickly without complication. Looking at these two equations, we can see that rearranging equation 1 to make x as the subject is simpler. So, we solve for x in equation 1. We have x is equal to 5 plus y. In the next step, we'll substitute the resultant value of one variable obtained in the other equation and solve for the other variable. Here we'll substitute the value of x, which is equal to 5 plus y in equation 2. Let's solve this equation further. Hence, the value of y is equal to 5. In the last step, we can substitute the value obtained of the variable in any one equation to find the value of the second variable. So, here we'll substitute the value of y, which is equal to 5 in equation 1. Let's solve this equation. Hence, the value of x is equal to 10. Therefore, the solution to the given pair of linear equations is x is equal to 10 and y is equal to 5. The solution can be verified by substituting the values of x and y in both the equations. Let's check this out. In equations 1 and 2, substituting x is equal to 10 and y is equal to 5. We can see that both the equations are satisfied. Next, we'll learn another algebraic method, the elimination method, to solve a pair of linear equations. The elimination method, as the name suggests, involves elimination of one variable by equating the coefficients of that variable in both the equations. Consider the pair of linear equations 5x minus 2y is equal to 14 and 3x plus 5y is equal to 120. In this method, the first step involves multiplying the equations with suitable non-zero constants so that the coefficients of one variable in both equations become equal. Here we'll multiply the first equation by 5 and the second equation by minus 2. By doing this, the coefficients of y in both the equations becomes minus 10. Please note that minus 2 and 5 are the coefficients of y in equation 1 and 2 respectively. The next step is to subtract one equation from another to eliminate the variable with equal coefficients. In this case, we'll subtract. So, we now subtract the fourth equation from the third equation. This eliminates the variable y and leaves the equation with just one variable. Now we solve the equation to get the value of the remaining variable, that is, x. Solving, we get x is equal to 10. The next step is to substitute the obtained value of the variable in one of the equations and solve for the second variable y. Substituting x is equal to 10 in equation 1 and solving. We get y is equal to 18. Therefore, the solution to the given pair of linear equations is x is equal to 10 and y is equal to 18. Let us verify the solution by substituting the values of x and y in both the equations. Substituting x is equal to 10 and y is equal to 18 in equations 1 and 2. We see that both the equations are true. In this pair of linear equations, we have obtained a unique solution for the pair of equations. We will now discuss the third method of solving a pair of linear equations, the cross-multiplication method. Let's consider the general form of a pair of linear equations. a1x plus b1y plus c1 is equal to 0, and a2x plus b2y plus c2 is equal to 0. Recall that when a1 divided by a2 is not equal to b1 divided by b2, the pair of linear equations will have a unique solution. To solve this pair of equations for x and y using cross-multiplication, we'll arrange the variables x and y and their coefficients a1, a2, b1 and b2 and the constants c1 and c2 as shown on the screen. Now, we write x divided by the product of b1 and c2 minus the product of b2 and c1. Following the same procedure for y and 1 and equating the three fractions, we get the expression as shown here. Now, let us try this method on equations we have earlier solved using the elimination method. Let's rewrite the equations in standard form. Now, let's compare the ratio of the coefficients of x and y. It is not equal, which implies that the equations have a unique solution. Now, let us apply the cross multiplication method and solve the equations. We get x is equal to 10 and y is equal to 18. The solution obtained is the same as the solution obtained by using elimination method. We can use any of these three methods to solve a pair of linear equations. However, the trick is to use the method that is simple and convenient. Consider this pair of equations. These equations are not linear. So, how do we solve such equations? Equations like these can be reduced to linear equations. Let's see how. First, we'll rewrite the equations as shown. Next, we'll substitute the fraction 1 divided by x plus 2 with u and the fraction 1 divided by y minus 2 with v respectively. So the two variables in the pair of linear equations are u and v. Now, using any of the three methods, we can solve for u and v in this pair of linear equations. Let's use the elimination method. Observe that the coefficients of v in both the equations are same. So we can eliminate v by subtracting equation 4 from equation 3. Simplifying, we get u is equal to 1 divided by 7. Now substituting the value of u in equation 4 and solving. We get v is equal to 1. we know 1 divided by x plus 2 is equal to u, and 1 divided by y minus 2 is equal to v. Now we substitute the values of u and v in 1 divided by x plus 2 and 1 divided by y minus 2 and solve for x and y. Therefore we get x is equal to 5 and y is equal to 3. Let's substitute x is equal to 5 and y is equal to 3 in equations 1 and 2. Next, we'll simplify the equations. As you can see, the linear equations are satisfied. Thus we have verified